Alright guys, this is Josh. I just want to, just like the last semester, I want to do a quick, short, what I call a crash video to industrial automation. I probably can't cover everything because I don't know everything. I think this video might be up to 20 minutes, hopefully a little less than that. But I think it's going to be worth it. Okay, so I think it's going to be around 3 questions. It's definitely going to be 3, that's what he said. And I think he said the marks are not going to be equal, but he probably is going to distribute it this way because he said at one time, someone said that he said at one time that if you know pneumatics, then you will know just enough to pass, you see. Someone said that 40% is the pass mark, 40% of 60 marks is 24 marks. So I'm thinking it's going to be 24 marks in pneumatics, 24 marks around SFC, then it's going to make this fewer, smaller marks, okay? Alright, so, and how we came about just these 3 topics is because it says it's 3 questions and answer 3. There's some questions that are repeated, okay, in the past questions. And then there's some areas of concentration he mentioned and he wrote out. And based on tutorials I did also. I don't know much about pneumatics, okay? I think this is the more complex part where most people are asking questions. I'm not going to do this because I don't know it yet, okay? So I'm going to do something on this. So if there's going to be another video, it's probably going to be on this one, which is actually fairly easy. So let's quickly run about how to do an SFC to FBD. He also mentioned basic ladders somewhere. Okay, what you have normally is you have control requirement and you convert that to an SFC and then you would convert it to an FBD. So it goes this way: control requirements, then you go over to making the SFC, okay, and then you either do a ladder or you do an FBD, but we know that it's probably not going to be ladder, it's going to be FBD. Okay, so yeah, so when you have the control requirements, don't let the picture or the diagram of the system intimidate you. Okay, in fact the more complex it looks, the more information it gives, although that means that's a lot more work, okay, usually. So but don't let that intimidate you. What you need is just this control requirements, basically, you know, working together with the diagram also. All right, so yeah, so I've put this. Oh, I didn't mention this part, very important. I would suggest you plan your time. There's a strategy, simple strategy of planning time. A lot of people probably don't do that, but if you're someone that does a lot of exams, you know, it's something you want to do at the beginning. So I think this is going to be 2 hours 45 minutes minus 15 minutes reading time. That's 2 hours 30 minutes. That's 150 minutes. So that's 3 questions. That's about 50 minutes per question. What does that help you do? When you're on a question, you're getting close to 50 minutes, you know you need to move. Okay, now they're not equal, okay, but at least it gives you a rough estimate of how much time you should spend on each question. That's what that is about. Okay, so I think you should use a pencil to start. You know, these are just nuggets that probably will help you. I want to start your drawing with a pencil so you can make your adjustments later. So the first thing you do, up until last week or 2 weeks ago, I did not know how to separate between states, outputs, transition. I was not sure, but following some of these methods helped me. So you want to start with a pencil, and then next you want to draw your states first from 0 to n, whatever the states are. Now you are the one that gets to state your state, okay? You get to mention that by yourself. You want to do your 0, 1, 2, 3, okay? Just do 0, 1, 2, 3 and all that. So, and that's because when you look at the way the things are, one might be tempted to think these are your states, state A, B, C. No, usually they are more like transitions most of the time, okay? So they are not your states, they are usually your transitions. So somewhere between your outputs or something like that. So the state, you just write it out, is going to be, you're going to be writing it out yourself. Okay, then next is you want to address every requirement. So this is very important. You check all of your requirements, every single one of them, you want to address them. Okay, and that helps you a great deal. Let's see an example here. Okay, now like here we have, I'm going to use this as an example because it's easier. Once you get the principle, you get every other thing. Yeah, so now when you follow this short method, you probably would not need this long stuff and then looking for how to compress it down to this. Okay, you probably will draw it straight up, and I don't think there should be any penalization for that. This is longer. You might find it difficult to find a way to match how this is a mirror image of this and how this looks like this. It may be a little difficult. Okay, so but anyways, yeah, it's just a quick one. I'm not going to read through all these, but just to show you a quick principle. Now, if the car is full, if the card is full at position A, okay, so you've written your 0 already, so you want to know how to leave this starting point. Is full, you know that's an F. Remember, you're using the pencil, so you can easily clean stuff if you make a mistake. The card is full, F, at position A, that's your A, and then the operator pushes go, that's G. The motor M1 is turned on. Let's say mistakenly I just write my M1 here for some reason, okay, thinking it's a transition, okay, until the point B is reached, okay, FAB, and I think, okay, B, like I said, I've said that earlier, B is going to be a transition. It's going to be something different from a state, okay? So you just go here and you check. Now, a quick thing you might also want to know about states and outputs is this, that states, well, states, you write that out yourself, okay? But outputs are actions or occurrences. Actions are things that are done manually, like G is pressed, and occurrences are things that happen automatically. Okay, so these, anything that looks like this are outputs, okay, and transitions are requirements before these outputs take place. All right, so use your pencils, you draw the states first, you address every requirement every step of the way, you also address every alphabet every step of the way. By alphabet, what I mean is these things, okay? So every other thing else here is just your state you've written yourself, maybe the timer here, okay? But then every other thing else is just these so-called alphabets, which are actuators and all of those things. All right, and these actions. Okay, so if you're mistakenly reading M1 and I1 here, for example, but you're going to take it out of there because you know M1 is a motor moving, is an occurrence that happened automatically. I1 is an action that you did manually, okay, and it is not a requirement, okay. I need to add this, it's not a requirement. Unlike G, it's something you did manually, but it is a requirement for something to happen, you see. All right, so that way then you move ahead. So, and then you keep the way you don't forget your I1, because you see that I1 was not mentioned in this, you see. Talking about here, it's a requirement, okay. You're following the requirements rather, but if you follow just this, you're going to forget this I1. How would you not forget I1? Is when you follow every so-called alphabet every step of the way, okay. So you check, what is I1, what does it mean? Before you go to this state and you start addressing this area of things, you just go check, have you checked I1, is it true for this part of the work? SFC, is the I4 true? So you discover the only one that is true is I1, then to make you put I1 here, and you flow all the way down like that. Okay, so to your logical expressions, you want to use arrows. Now, Dr. Salah didn't do this, but I think it helps. Okay, it helps in the sense that when you start writing your logical expressions, there was something I asked him, okay, this was my mail to him, I just screenshot it here. Okay, literally, you have to write 1, 2, 3, 4, 5 logical expressions times 2, because each state has a reset. Set and reset, set and reset. You write that, and then you write for these outputs also. Okay, so when you want to write the logical expressions, which is the next step here, okay, it's also the next step, something you need to do somewhere here, okay, before you get to your FBD finally. Okay, when you're writing your logical expressions, you're basically transitioning from this diagram into logical statements like this. So I was asking him that if you're activating state 1, which means what happens before this 1 takes place, it's going to be state 0 and F and A and G, okay? Or is it going to be that, which is state 0, F and A and G, blah, 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 then you also add this to it. Because another thing that makes state 1 happen is when you're coming from 2 and then 2 is looped back like this. Okay, that's another thing that activates state 1. So, and then it confirmed that the second part is correct, which literally was obvious just before. Just about at the end of the tutorial we had yesterday, that's the correct thing to do. You need to note this then. If we have a straight line, we're going to the FBD now. The total number of blocks is just the number of states. In fact, basically, technically, is the total number of the logical statements you've made. But sometimes, just to make it neat and nice, they kind of overlap in a way such that you can make it like what he did here in the tutorials. Okay, now quick one, just to help you keep things in perspective. If we have a straight line system like the one he did in tutorials like this, usually the number of expressions you have at the end of the day will be the number of states times 2, because there's a set and reset for every one. But if it's also straight like this, okay, the reset for 0 is going to be the set for 1. The reset for 1 is going to be the set for 2. So at the end of the day, you end up with just something condensed, such that the number of blocks you have is going to be 7, because we have states 0 to 6, if you noticed, yeah? So you're going to have 7 blocks at the end of the day. Okay, and if we count it, yeah, it's going to be, this is 1, because this is equal, you see. So this is equal, that's 1, 2, 3, 4, then 5, 6, 7, like that. But it's not always like that, it's just sometimes like that. But it's good you have that in mind, and it's going to be that plus the expressions for the outputs. So identical outputs are going to have similar blocks. Okay, so basically when he equated them, what he had was, what he had was just about this: 1, 2, 3, 4, 5, 6, and that brought about 1, 2, 3, 4, 5, 6 blocks. Okay, so to put that in perspective, this was my question for him. Okay, and of course the second one is correct. Now what I meant arrows, I think I forgot about that. You want to put all of these ones are usually going up like this. Okay, so what that's going to help do for you is that when you want to write the reset for 0, you're not going to be tempted to think one of the expressions for the reset for 0 is going to go this way. No, it's not, because this is always moving upwards. Okay, but it's going to work as a set for 1. Okay, so this is correct expression. So this addressing is not necessary. Okay, he said that is not necessary. Okay, in the exams. So in this case, the reset for 0 is not necessarily equal to the set for 1, because we have an extra OR expression here. Okay, and that's in that picture right there, you see. Okay, because we have that extra OR, so reset for 0 is not necessarily equal to the set for 1, because there's an extra OR expression here. So this, I'm going to modify this. If it was a straight line deal, it's going to work, but it's not. So this is going to be maybe something like this. Okay, I hope this is not going to be too complex. Well, you might want to draw them separately, but technically this is correct. Okay, and this can come over to the center. Okay, let's see if that's going to grab everything. Yeah, so this is straight to this. Okay, because this expression here, this bit of expression here is this block here, and this is true for the reset of state 0, R for state 0, but it's also true for one part of the set for state 1. That's why I'm just doing something complex like it, but normally I should draw this a second time and map it to this straight up on its own. Okay, but technically it is true. Okay, so you have that. And what else? Comments. Yeah, so please put comments in your diagrams. It helps to, I mean, you can write anything in your comments. You can write stuff like this. These are comments. Okay, they are not addresses like we're asking him. So you can write comments. What that helps you to do, he says there's more marks for that, but that also helps you if you use a convention that is different, like he was using X here instead of state. You could just easily mention it here. You could see anything, Salah, I don't want to fail this exam, that must, something like that. So that's that. I hope I've covered everything.